So here we have the function f of x equals 1 over x on the interval from 1 to 16, and we want to find the value or values of c that satisfy the conclusion of the mean value theorem. Well, what is the conclusion of the mean value theorem? Well, the mean value theorem says that if your function is continuous and differentiable on the interval, then there's going to be some value in that interval that equals the average rate of change of the function over that interval. So what is the average rate of change of our function on the interval from 1 to 16? Well, that's going to be our function evaluated at 16 minus our function evaluated at 1 all over 16 minus 1. So that's going to be what? Well, what is our function evaluated at 16? Well, if f of x equals 1 over x, then f of 16 is going to be 1 over 16. And then we're going to subtract f of 1, which is just 1. We have all of that divided by 15. So that average rate of change is going to be negative 15 over 16 divided by 15, which is just going to be negative 1 over 16. Now we need to check that our function is continuous on that interval and differentiable on the open interval 1 and 16. Well, our function is continuous on 1 and 16 included, and differentiable on the open interval, because the only value we have an issue with here is x equal to 0. That's what causes our function to be not continuous and differentiable, but 0 is not in this interval. So on the interval 1 to 16, we're okay. So the mean value theorem then tells us there must be some c, some value c, between 1 and 16, such that the derivative of our function at c equals that average rate of change that we found, which was negative 1 over 16. So now all we have left to do is figure out what is that value. So what is f prime of c? Well, if f of x equals 1 over x, which we can think of as x to the negative 1 power, then f prime of x is going to be negative x to the negative 2 power, or negative 1 over x squared, which means that f prime of c is just negative 1 over c squared, right? So putting that here, we have that negative 1 over c squared would equal negative 1 over 16. Well, the only way that can happen is if c squared equals 16, which would mean that c could equal either negative 4 or 4. Now we're looking for a value of c between 1 and 16, so we're going to throw out this value of c since it doesn't fall between 1 and 16, and the answer that we're looking for is c equal to 4. So what does this all mean? Well, this means if we were to graph f of x equals 1 over x, and look at the graph between 1 and 16, and draw the secant line that joins those points, then at the value x equal to 4, if we found the equation of the tangent line, it would have the exact same slope as the slope of that secant line joining 1 and 16.